The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hello and welcome back to David Mackey's Shiny Side. This is show number 488, 880 and 400. That's a cool number. And we're talking about the rational and logical approach to the extraterrestrial question. That's what we're going to talk about in the second hour here with my esteemed co-host, Dave.
That's what he said.
Without further ado, and if you do find it within your means to donate to the station, that would be greatly appreciated. This is listener-funded radio, meaning that you, the listeners, you determine the fate of the station largely, because there are no corporate sponsors, anything like that, and all of the hosts do this for free, gratis, with no compensation. So if you like what you hear, not just us but everybody else, especially Solaris just coming before us and Gerbear just behind us, please do donate if you can. Now, I do want to share with you a section from one of my favorite little books by Frederick Brown. It's called What Mad Universe. It was written in the 1950s, the golden age of science fiction, as far as I'm concerned, or many other people as well. And it's a slightly abridged section. Okay? Come, let me show you what you may be saving Earth from. Would you like to see an Arcturian? A live Arcturian? Why, sure, why not? The sphere that was Mackie floated across the room and Keith followed. A door swung open, revealing just beyond it a second steel-barred door that led to a cell. With the opening of the door, a light flashed on just inside the cell. Keith took a step closer to look through the bars. He took a step back, several steps, even more quickly. He felt as though he were going to be sick at his stomach. He closed his eyes and swayed dizzily. Horror and nausea almost blanked him out, and he'd only had a quick, indistinct glimpse of part of the Arcturian. He didn't really know, even now, what an Arcturian looked like, but he knew he didn't want to know. Even seeing one behind bars and helpless might drive a human being mad. It was alien beyond all imagining. And that's really the point I'm trying to make here, and I haven't come across a better way describing it than Frederick Brown did in What Mad Universe back in the 50s. Any alien life form that we find out in the world will be extremely alien, pardon the pun, but it will be completely different to anything we can possibly imagine or experience, right? Now, the problem of our place in the universe, extraterrestrial civilizations, visitations, UFOs, unexplained phenomena, and stories thereof that go back into the dim and distant past of our species are fundamental to our very existence. We must find answers, and we must find them soon. Unfortunately, there are complexities at play here that most of us do not consider. The Shiny Side Out will attempt to shed some light on the rational and logical explanations that offer themselves up to us. The Earth as we know it is populated on the surface. Naturally, many creatures and plants live below in the oceans and in the bowels of the Earth. What if we humans that live on the surface are but third world nation players in comparison to the civilizations that dwell under the ocean or within the Earth? The surface, in other words, is the true developing world. A lot of strange events and activities will start to make sense. And these are the obvious anthropomorphic problem with the alleged ETs, constant sighting of USOs, highly advanced tech effects, the Skinwalker Ranch, Bigfoot encounters, etc., USO encounters, disappearances in national parks. Also, stories of inner Earth societies, civilizations and cities, mutilations, abductions, and seductions. Right? I mean, why would that happen? Checking on genetic experiments? Checking on introduced livestock? Do crop circles fall into the same category? Why would not non-terrestrial races give a thought to cows or crops, for that matter? It would make sense if we're talking about a checkup on introduced species after a great catastrophe or thereabouts. Ancient stories do tell us that domesticated animals and agriculture were taught to us by gods. Another point, interbreeding is another story we hear a lot about, but in modern times and in ancient accounts, right? Any species not native to this planet coming here interbreeding with us is laughable, unless there was a seeding event in the dim and distant past, and that's a whole different story. Even closely related species such as horse and donkey can only produce sterile mules. The chance of a truly extraterrestrial race, no link whatsoever to us, being able to interbreed with us is non-existent. We are not disputing the existence of the above-mentioned phenomena, such as Bigfoot, UFOs, USOs, etc. In fact, the Shiny Side firmly believes that we are living in a multiverse far stranger than any of us can begin to imagine. The problem lies in the vastness of space, and no, not just the distances involved, but also the volume of stars and potential planets. The distance issue, we think, is not of a major importance. Faster than light travel is only a problem that needs solving, no matter how fundamental we think the speed of light limit is. Certainly, quantum entanglement has shown us that we do not understand space like we thought we did. In years to come, we will look back upon this period, as we're now looking back at the 18th and 19th centuries, where trains going faster than 80 miles per hour and heavier than air-powered flight were thought to be impossible. This does not mean that we can ignore the physical facts of the universe we inhabit. It is vast and chock full of stars and action-packed with planets. This very vastness and volume of planets is what we're addressing here. The question remains, why in the vastness of space would anyone pick Earth as a place to visit and investigate with great diligence? Dave?
Understanding the scale of the problem. The Milky Way is the galaxy that includes our solar system, with the name describing the galaxy's appearance from Earth. Has a hazy band of light seen in the night sky formed from stars that cannot be individually distinguished by the naked eye. The term Milky Way isn't Nestle. It's a translation of the Latin via lactea from the Greek, whatever that is, galactikos Kyklos, meaning milky circle. From Earth, the Milky Way appears to be as a band because its disc-shaped structure is viewed from within. Galileo Galilei first resolved the band of light into individual stars with his telescope in 1610. Until the early 1920s, most astronomers thought that the Milky Way contained all of the stars in the entire universe. Following the 1920 great debate between astronomers Harlow Shapley and Herbert Curtis, observations by Edwin Hubble showed that the Milky Way is just one of many galaxies. The Milky Way is a barred spiral galaxy with the estimated visible diameter of between 100 and 200,000 light years. Recent simulations suggest that a dark matter disk also containing some visible stars may extend up to a diameter of almost 2 million light years. And I have to say, my own little opinion here is dark matter doesn't exist. But that's fine. The Milky Way has several satellite galaxies and is part of the local group of galaxies, which form the part of the Virgo supercluster, which is itself a component of the Laniakea supercluster. It is estimated to contain 100 to 400 billion stars and at least that number of planets. The solar system is located at a radius of about 27,000 light years from the galactic center, on the inner edge of the Orion Arm, one of the spiral-shaped concentrations of gas and dust. I'm going to also suggest here that because of the shape of these arms, they've reversed the time in simulations to work out that this is a third or fifth, I can't remember now, third or fifth galaxy having been consumed into the Milky Way galaxy. And our spiral arm happens to be the remnants of one of those collisions or, amalgamations of galaxies. How does that sound? I hope that makes sense to you. Meki.
Absolutely. Now this is an article from March 23, 2020, and it's entitled astronomers have found the edge of the Milky Way at last. Our galaxy is a whole lot bigger than it looks, and it was hinted in the information Dave just shared with you. New work finds that the Milky Way stretches nearly 2 million light years across, more than 15 times wider than its luminous spiral disk. The number could lead to a better estimate of how massive the galaxy is and how many other galaxies orbit it. Astronomers have long known that the brightest star of the Milky Way, the pancake-shaped disk of stars that houses the Sun, is some 120,000 light years across, the brightest part of the Milky Way, right? A vast halo of dark matter, again, we're not sure, well, no one is really sure about dark matter, presumably full of invisible particles, engulfs both disks and stretches far beyond them. But because the dark halo emits no lights, its diameter is hard to measure because you can't see it. Alice Deason, an astrophysicist at Durham University in England, and her colleagues have used nearby galaxies to locate the Milky Way's edge. The precise diameter is 1.9 million light years, give or take 0.4 million light years. The team reported February 21st, 2020, in a paper posted at rxiv.org. To put that size into perspective, imagine a map in which the distance between the Sun and the Earth is just 1 inch. If the Milky Way's heart were at the center of the Earth, the galaxy's edge would be 4 times farther away than the Moon actually is in relation to that map. That is, so that's pretty far. To find the Milky Way's edge, we're dealing with scales here which are very hard for the human mind to imagine. Right? That's why we need to talk about it. It's really important. And that's why for the longest time human beings thought that the Earth was at the center of the universe, because anything else was unimaginable. Right? I mean, clearly we are the pinnacle of creation. Therefore, the Earth must be at the center of the universe.
No, the universe was made just for us.
Just for us. In fact, this belief was held so strongly that people that spoke up against it and said, "Oh, we know it's not actually the Earth, it's the Sun that's the center, and the Earth are also the Sun." They were threatened with being burned at the stake, and some, in fact, were burned at the stake. Right? And then forget about when the Sun no longer was the center of the universe. But we found we are out on the Orion Arm somewhere in the galactic wastelands. As it were,
what do you mean? We live in the burbs.
That's it. The outer suburbs of the Milky Way.
There's a bit of humility right there. Humble pie.
It's incredible though if you think about it. But these are vast scales, okay? And it's really important that we understand this. That's the whole point of the argument we're trying to make here. The vastness of the numbers we're talking about. To find the Milky Way's edge, Deason's team conducted computer simulations of how giant galaxies like the Milky Way form. In particular, the scientists thought cases where 2 giant galaxies arose side by side, like the Milky Way and the Andromeda Nebula, our nearest giant neighbor, because each galaxy's gravity tugs on the other. The simulations showed that just beyond the edge of a giant galaxy's dark halo, the velocities of small nearby galaxies drop sharply. Using existing telescope observations, Deason and her colleagues found a similar plunge in the speeds of small galaxies near the Milky Way. This occurred at a distance of about 950,000 light years from the Milky Way's center, marking the galaxy's edge, the scientists say. The edge is 35 times farther from the galactic center than the Sun is. That's how far out it actually goes. That's pretty far if you think about it. Although dark matter makes up most of the Milky Way's mass, the simulations reveal that stars should also exist at these far outer distances. Both have a well-defined edge, Deason says. The edge of the stars is very sharp, almost like the stars just stop at a particular radius. Dave?
I want to also say that at the beginning of this year, as soon as that, 6 months ago, they discovered that the rotational speed in a galaxy like ours, a disc-shaped galaxy with a strong core, was faster around the edge than it was in the middle, which is counterintuitive because, like water going down the funnel of a drain, it spins slower around the outside and faster on the inside. And they've found the complete opposite, which actually renders the dark matter hypothesis out the window. It's in the bin. It's gone. Don't have to worry about the words dark matter ever again, because they've now disproved that and that the mass of the stars, the visible stars, is sufficient to be able to work it. However, there's a galactic horizon, or the planar galaxy plane, which it extends out, like you see in the sci-fi movies when there's an explosion. Now that we've learnt, the explosion goes across basically the equator of the spin of the object. It's less likely to go north and south, but rather east-west out like a record from the middle. And that same disk of invisibleness, there's a new word, which exists in our own Milky Way galaxy, is also a gravitational disk, which can, at that plane, hold on to items much further away. All right? So it's not the dark matter. It all kind of starts to make sense when you look at it from that perspective. All right, back to the text. The universe versus the observable universe. The size of the whole universe is currently unknown. It might be infinite in extent. Some parts of the universe are too far away for the light emitted since the Big Bang, which is also only a theory, to have had enough time to reach Earth or space-based instruments. They may be, the Hubble or other telescopes we have now outside of the Earth's atmosphere. And therefore, those objects might lie outside of the observable universe. In the future, light from distant galaxies will have had more time to travel, so additional regions will become observable. Well, that's not entirely true. I've got to tell you, my belief, Mekki, I don't want to stop and start too often, but my belief is that light deteriorates over time, and that we'll only ever be able to see a certain distance because the light deteriorates. It downshifts into another frequency, and what we see as microwave background radiation used to be light. That's what I think. So that 3 degrees Kelvin used to be light. It wasn't the Big Bang at all, and that we live in a universe that is truly infinite. Yeah, but from your pocket you can only see a certain distance. Imagine it be like a smog effect on only being able to see a certain kilometer away, and after that it's just nothingness. Similar effect. That's what I believe we see. However, back to the text. Owing to Hubble's law, not the Hubble, but Hubble's law, Edwin Hubble being, regions sufficiently distant from the Earth are expanding away from it faster than the speed of light. That's the special relativity equation that suggests that. I've got to stop again after this paragraph. Preventing nearby objects in the same local region from moving faster than the speed of light with respect to each other. But there is no such constraint for distant objects when the space between them is expanding. Then you should see uses of the proper distance for a discussion. And furthermore, that the expansion rate appears to be accelerating owing to dark energy. Once again, preposterous. The only time that physicists refuse to use the Doppler effect to its true extent, is the only time they want to use it is when something's in motion, but they don't want to talk about the deterioration of light over time, and therefore the effect is associated with that. Because the moment they do, the Big Bang is out, the universe is not expanding at the speed of light, or the further away from you see. It isn't. It just becomes where it is. It's just old light.
Look, and that's the thing there, right? We don't know if the universe is expanding. It appears to be expanding, right? It
only appears to be because you adhere to the Doppler effect.
Well, that's correct. And what they're saying is, so if you're blowing up a balloon and the surface of the balloon, something is moving at the speed of light, if the balloon also expands at the speed of light, then you should really be seeing a massive increase in the speed of that object, because it has its own speed of light plus the additional speed of light that's, in extreme scenarios, that's coming from the expansion of the balloon.
Yeah, so if you partly inflate a balloon so it's enough to be able to use a Sharpie and draw 3 dots, like in a triangle, make it an equilateral triangle where all the dots are equidistant from each other, and then start to measure the distance between the dots, and then as you inflate it, every dot is seeing the other dot move away at the same rate, and as the balloon is inflated even more, the rate increases in distance, and that's that description of how that works. But it's only a description to match the theory, and the actual data is being ignored because they want to stay on that theory.
Yeah, look, and that's right. The number of issues with it, and the single biggest issue with the expanding universe for me personally, unless you take the multiversal approach, and you look at the multiverse as bubble universes, what is the universe expanding into? Okay,
that's right. But there's nothing there, Mackie.
Well, but okay.
It's a bubble. There's nothing on the other side of the bubble.
Well, again, that's fine, but physical expansion assumes the expansion into something. So it can't be nothing, because if there were nothing, it couldn't expand into it. Now, it's see, when the people say nothing, they imagine an empty room or just the absence of stuff, right? But nothing actually.
It's an absence of a universe,
including the absence of a space to expand into.
That's right.
Okay,
that's right.
That's what nothing actually means. People don't really understand this fully, and it's important that we do understand this, because the question is, what on earth is the universe expanding into? But that's a whole different question for a whole different show, for a whole different cycle. But suffice it to say,
in the context of this discussion,
we don't understand space, and I think I said it in the opening statement. That we don't understand space. We just don't know, simply because of the quantum entanglement. That's the one thing that we know actually works, but completely contradicts everything relativity tells us, including what we think we know about space, because it's communication that is instantaneous, or information exchange that's instantaneous between two entangled particles. Instantaneous. Impossible. That's impossible. No matter how far apart they are, it's impossible in our concept of space.
Hey, Mackie, I'm going to suggest something. When we see light, what happens to it after we've seen it?
It keeps moving.
Nope.
We eat it up?
It's gone.
Well,
is that incredible or not?
Well, I don't know if that's true.
Because a cat can, take all of the light that's going into its eyes and focus it out like a torch, and actually see things in the dark by using all of the available light.
Right.
But humans don't have that ability at all.
Yeah, but the photons don't cease to exist. I mean, that's a.
I know what it means. Yeah, but since light, when you're anywhere and you're viewing anything at all, you're not projecting light out of your eyes.
No. Okay, so there are two things. So some surfaces reflect a certain spectra of light, and the reason we see color is because that's what's reflected back. Right? The only reason you see something green or yellow or whatever it might be is because that's the spectrum of light that is not absorbed by the object.
That's correct.
That's what's reflected back to you. So black absorbs all light. So our pupils happen to be black. So all light is absorbed into the pupils. Now, what happens is, so all the frequencies that the photons could possibly have are going into your retina at that point, right? But they don't stay there, right? They pass right through you, because that's what photons do, right? Having very little mass, as it were. And in fact, the photon itself is both a particle and a wave, and that goes into a whole different kind of anger. But ultimately, the photon keeps moving, right? And unless it hits something that reflects that particular wavelength of the light, all right, it just keeps going, and that's what it does. Now, but to Dave's point, if it hits enough surfaces, right, the frequencies are whittled down, and that's really where we're going with this here, right? And I'm hoping I'm supporting you in my explanation. As you have photons going through different surfaces, different things, if you will, parts of it, part of the frequency of the photon is reflected back, meaning the photon effectively loses that frequency band, right? Until it is quite possible the only thing that's left is microwave background radiation. That doesn't get reflected by anything. It just keeps going. And maybe that's what the background, or the noise, everybody's talking about this microwave radiation in the background of the universe. And quite possibly, once everything has been reflected, or once, let's be more scientific, once all the frequency have been stripped from the photon and only microwave radiation remains, that's what it is.
That's what, yeah. So being stripped or aged. And I believe it's an age thing.
When you say aged, but I mean, the frequency can no longer be there. So what happens to it if it's not reflected?
Yeah, so if I was to suggest that it downshifts in its energy...
So the frequency changes.
That it doesn't matter what unit, like what galaxy we're in, being able to stare far enough away from wherever you are, you will always see the apparent 3K background radiation, because that's what the poor light has eventually devolved to.
I understand what you're saying.
It's only the same. It's the same. It's just energy.
We're in violent agreement. Yeah, I think.
Yeah, yeah, that's okay. I'd like to be able to take that offline and talk to you about it.
No, I think we agree with each other. Is my point completely.
Yeah, I agree. Yeah, I agree too. So, observable universe, Mickey.
Indeed. Now, the observable universe is a ball-shaped region of the universe comprising all matter that can be observed from Earth. Pretty straightforward. Or it's space-based telescopes and exploratory probes at the present time, because the electromagnetic radiation from these objects has had time to reach the solar system and Earth since the beginning of the alleged is mine, cosmological expansion. There may be 2 trillion galaxies in the observable universe, and it's important to focus on these numbers, everybody, because that's the point of the show. Although that number has recently been estimated at only several hundred billion based on new data from New Horizons. So again, could be several hundred billion or 2 trillion. It's still a very large number. Assuming the universe is isotropic, the distance to the edge of the observable universe is roughly the same in every direction. That is, the observable universe has a spherical volume, a ball, centered on the observer. Every location in the universe has its own observable universe, which may or may not overlap with the one centered on Earth. All it means is that we can only see what we can see. Do you know what I mean? That's really what they're saying here, right? We can only see as far as we can see and no further, because we haven't got the technological means yet. Never mind that the light, they say, hasn't had time yet to travel to us. It becomes very complicated and very metaphysical if we look at this too closely. Bear in mind only the numbers, right? Let's talk about the lower number, several hundred billion galaxies. And a galaxy is like the Milky Way, which itself has, 100 billion stars. So we're talking, 100 billion by 100 billion, and then multiply that, by the number of potential planets. Life should be teeming, but we'll get to that. And that's my segue, my friend, into the Drake equation. Dave?
I know, I absolutely love this one. So the Drake equation is a probabilistic argument used to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. The equation was written in 1961 by Frank Drake, not for the purposes of quantifying the number of civilizations, but as a way to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence. As we know today, it's named is SETI. I remember used to run that on my PC, and it was...
Me too.
Yeah. I have a number of other ones that I run now, because that's closed down for sharing. The equation summarizes the main concepts which scientists must contemplate when considering the question of other radio communicative. It is more properly thought of as an approximation than a serious attempt at deterministic estimations of precise numbers. Criticism related to the Drake equation focuses not on the equation itself, but on the fact, I love the word fact in a debunking case, that the estimated values for several of its factors are highly conjectural. The combined multiplicative effect being that the uncertainty associated with any derived value is so large that the equation cannot be used to draw firm conclusions. Oh, look, to be honest, there's a number of things that it has. So to work out the number of civilizations in the galaxy that can communicate right now is a very complex one. So it takes into consideration the average rate of star formation, the fraction of those stars that have planets, and then the average number of planets that could be potentially, support life, like in the Goldilocks zone, the fraction of planets of that could support life that actually develop life at some point. Then from that, the fraction of planets with life that actually go on to develop intelligent life, i.e. civilizations. And then which civilizations that develop technology that releases detectable signs of their existence into space, like Muggins here. Our civilization did that with, the first broadcast being that of Hitler at the Olympic Games, wasn't it?
That's right.
Right, so that's good for us doing that. And also the length of time for which such civilizations release detectable signals into space. Now, right now, we're still releasing signals into space, but we're doing it less and less and less and less. And within the next 10 years, I suspect we'll have almost nothing. Because the internet is doing it rather than we're broadcasting like mad people into an environment where we're broadcasting to unknown civilizations. And I think that's definitely something we need to realize, that that's now where the position of science is. Hey, maybe we shouldn't have done that, right? But that's also a mistake that a lot of places would make the same mistake. Criticism of the Drake equation follows mostly from the observation that several terms in the equation are largely or entirely based on conjecture. Star formation rates are well known, and the incidence of planets has a sound theoretical and observational basis, but the other terms in the equation become very speculative. The uncertainties revolve around our understanding of the evolution of life, intelligence, and civilization, not physics. No statistical estimates are possible for some of the parameters, where only one example is known, us. The net result is that the equation cannot be used to draw firm conclusions of any kind, and the resulting margin of error is huge, far beyond what some consider acceptable or meaningful. That's certainly in the science area. They didn't want to be told what to do, Mackie. If they came up with the idea themselves, they'd take all the credit for it. One reply to such criticisms is that even though the Drake equation currently involves speculation about unmeasured parameters, it was intended as a way to stimulate dialogue on these topics. Then the focus becomes how to proceed experimentally. Indeed, Drake originally formulated the equation merely as an agenda for discussion at the Green Bank Conference.
And look, it was just an intellectual stimulation, for the first SETI scientists. But let's be clear though,
it worked.
Absolutely. But the Drake equation is limited in a number of ways, because, like Dave just said, the Goldilocks zone. Now, I dispute that our definition of life is the only definition of life that
Correct.
exists, and we'll get to that a little later, maybe not today, but certainly next week, as to what that actually means from a biochemical point of view, right? So not only that, but all we really know, and not even that well, is us. So we know this planet, and we know the solar system, more or less. We know the surface of the moon far better than we know the bottom of the oceans on our own planet. So our knowledge is extremely limited. We might think we know it all, but we do not. So to put this equation together, it was actually ingenious, I think, but it also, in my opinion, hinged on a couple of flawed assumptions. And the key ones here, again, are the definition of life, what life actually is, right? And then also what that would entail as far as intelligence and civilization are concerned. So we know how many stars are forming roughly. We know we've observed exoplanets, etc., etc. Now, do we know it all? No, we don't. And later on, we'll talk about type 1, type 2, and type 3 civilizations and what that means. But bear with me while I'm going to tell you about the Fermi paradox, which sort of arises straight out of the Drake equation, if you will, right? A civilization lasting for tens of millions of years could be able to spread throughout the galaxy, even at the slow speeds foreseeable with our own current technology. So we can actually make it to the next star system, even though it might take decades to get there, but we could make it there. However, no confirmed signs of civilizations or intelligent life elsewhere have been found, either in our galaxy or in the observable universe of their, roughly 2 trillion or several hundred billion galaxies, whatever the number might be. Again, I'll get to the flaw in this argument, maybe not today, but certainly next week. According to this line of thinking, the tendency to fill up or at least explore all available territory seems to be a universal trait of living things. So the Earth should have already been colonized or at least visited, but no evidence of this exists. Hence, Fermi's question, where is everybody? So that's Fermi's paradox. Where is everybody? Now, I will strongly argue against Fermi's question, where is everybody? Because personally I think, there is ample evidence of visitations, and certainly even Earth-borne space flight, potentially even intergalactic space flight. Plenty of it, but we'll get to that as well in due course. So, but nonetheless, let's stick with what the scientists believe. So Fermi asked, where's everybody? A large number of explanations have been proposed to explain this lack of contact. A book published in 2015 elaborated on 75 different explanations. In terms of the Drake equation, which we just discussed, the explanations can be divided into 3 classes. The first one, few intelligent civilizations ever arise. This is an argument that at least one of the first few terms that we discussed in the Drake equation has a low value, right? The most common suspect is Fi, which is the rise of intelligence. But explanations such as the rare Earth hypothesis argue that Ne is a small term, like the Goldilocks zone that Dave referred to. The second, so essentially what it means that one of the terms in the equations is just extremely low. Either the planets don't form right, or intelligence simply doesn't arise. Okay, that's class number 1. Class number 2, intelligent civilizations exist, but we see no evidence. Meaning that FC is small, which in this case means the fraction of civilizations that develop a technology that releases detectable signs. So essentially, these civilizations don't actually release any detectable signs. Okay. Typical arguments include that civilizations are too far apart. It is too expensive to spread throughout the galaxy, or civilizations broadcast signals for only a brief period of time, or communication is dangerous, and many others.
Expensive.
Why would you?
That's a joke.
I know, right? I mean, dangerous. Again, why would you invite a species that might eat you to your planet, right? I mean, look, but
we
again,
should sell them fractional reserve lending.
We should so do that. Print as much money as you want. Build your civilization with debt. But again, this is really the problem with both the Drake equation and Fermi's paradox. We're looking at it from a human point of view, but I will get to that in a second. And then the final point here, or the third category, is the lifetime of intelligent communicative civilizations is short, meaning the value of L in the equation that we discussed is small. Drake suggested that a large number of extraterrestrial civilizations would form, and he further speculated that the lack of evidence of such civilizations may be because technological civilizations tend to disappear rather quickly. Typical explanations include it is the nature of intelligent life to destroy itself. Also, it is the nature of intelligent life to destroy others. And then finally, they tend to be destroyed by natural events, and so on and so forth. These lines of reasoning lead to the Great Filter hypothesis, which states that since there are no observed extraterrestrial civilizations despite the vast number of stars, at least one step in the process must be acting as a filter to reduce the final value. According to this view, either it is very difficult for intelligent life to arise, or the lifetime of technologically advanced civilizations, or the period of time they reveal their existence must be relatively short. Okay? An analysis by Anders Sandberg, Eric Drexler, and Toby Ord, in case you want to do further reading, suggests a substantial ex-ante probability of there being no other intelligent life in our observable universe, meaning Earth is unique. You were all right. Now, I do want to quickly share this, and then I hand it over to my esteemed colleague. Now, the answer to Fermi's paradox might simply be that we cannot perceive them because the other civilizations, because they might be too advanced or simply too different for us to recognize as sentient life. It is also feasible that they do not wish to interact with us, either because they don't want to, or do not understand the need to, or might even be guided by some sort of prime directive. That, of course, is complete speculation, as we have no way to imagine how a truly alien life form might reason, or if reason even comes into it. Now, I want to quickly go back to the very beginning, when I shared with you the extract from What Mad Universe by Frederick Brown, and the last sentence I have in that extract was, "It was alien beyond all imagining." It was alien beyond all imagining. Okay, and that's really the crux of it here. Now, Dave, why don't you share with us what Nikolai Kardashev did?
Nikolai Kardashev, I can't do it with the rolled R. A Russian astrophysicist proposed a scale by which to measure a civilization's technological achievement. And there's 3 types. A Type 1 civilization, also called a planetary civilization, can use and store all of the energy available on its planet. Kind of similar to what we do. Type 2 civilization, also called a stellar civilization, can use and control energy at the scale of its planetary system. A Type 3 civilization, also called a galactic civilization, can control energy at the scale of its entire host galaxy. Wow. Now, we're nowhere near that. With us and our little dinghy, a little dirigible if you're in the US. In this scale, our current civilization would be a Type 0, meaning we are not even on the scale. A Type 2 civilization, for example, would be able to build a Dyson sphere. Considering the assumed age of the universe, which is also incorrect at 13.7 billion years, and our Earth is meant to have been around for about 4.5 billion of those years, it seems almost staggeringly implausible to assume that there are no Type 1, 2, or even 3 civilizations out there. If there are Type 2 and Type 3 civilizations anywhere in the galaxy or neighboring galaxies, that we might simply be too primitive to understand what we are seeing when we are looking at their monuments, such as a Dyson sphere, maybe black hole engines, we don't know, sun clusters as ornaments, and the like. That's true, all of that is true, and it's a great question to pose to our science, which wraps itself around what it sees and how it measures others. Just like that, it might be too expensive to travel. Preposterous funny, right? Idea.
It is funny.
That some other poor schmoes out there are on the treadmill.
But see, that's the problem. We superimpose our thoughts, motives, psyche, if you will, onto life. We couldn't imagine, right? I mean, if it's true, I'm talking about truly alien.
Yeah.
No genetic link to us, no seeding event, nothing like that. But like life that has developed on another planet completely on its own, right? And it rose to consciousness, sentient life, whatever it might be, but completely unrelated to us. And we get into the biochemistry of what that might look like. Not today, we won't have time, but certainly next week. And we will see that. We really shouldn't do that. It's like this. Let's say, give you a simple example, right? Let's say you're a peasant in Europe in the year 1200, right?
I've got a cunning plan, my lord.
Exactly, and we have to do that yet, right? The Monty Python thing, because that's just gold. But the point is, and by the way, it should be free of IP now. It's been many decades since they did that. But ultimately, let's say you are that peasant, right? And your life is essentially working for your feudal overlord, your baron or your duke or whatever have you, and you're tilling the earth all day long, right? That's what you do. And then you're hearing about these people that are sailing the world's oceans, going to new worlds, as it were, like new continents, exploring. And then, by the way, you still think that the earth is flat. So it's eventually when you get to the end of the ocean, you're going to fall off the edge. Mm-hmm. Now that's your scientific worldview. And you might not even know that because you're a peasant, but your lord might know this. And yeah, that's right, nice guy, black-eyed eyes, beautiful. But ultimately, you have your worldview, and you're trying to superimpose it onto everything else. So you imagine that if there were other lands beyond the sea, they would be like your land. There would be feudal overlords, and people like you would be working the soil. You can't imagine potentially civilizations or peoples like the Aboriginals of Australia, or the First Nations people of America, or the African tribes, for argument's sake. You can't imagine, and you certainly can't imagine that they would be any further advanced than you are, because how could they be? Because you are the pinnacle of civilization. You're going out there, doing everything, right? And by sending radio signals out, and as I said this last time as well, let's say you're sending out radio signals into space like we are, here we go, and if you lived in the peasant's time, it'll be like the peasant building a fire in his backyard, really smoky fire, using some wet wood or whatever, so you get some nice black smoke going, and then expecting people in the Americas to see him. So he sees somewhere in Central Europe starting a fire and setting up smoke signals and hoping that those smoke signals will reach some potential people on the North American continent. He doesn't even know the North American continent exists, but he sends the smoke signals up anyway in hopes of reaching those people. It's completely insane. It's completely insane. Civilizations that have developed potentially well beyond ours probably wouldn't even know what to do with radio signals, right? It's or other primitive forms of communication, because we said this last time as well. We talked about this. If you were in fact a galactic civilization, let's say you had several solar systems and you're spreading across the eastern arm of the galactic swirl, how do you communicate? Well, you communicate by quantum entanglement. That's what you do, or something like that, right? Because you need instantaneous information transfer.
Subspace,
it's no good. Yeah, subspace, bingo, something like that. Because if you're relying on radio waves or anything that travels, with the speed of light, forget about it. You can't run an empire like that. You can't run a civilization like that. You cannot. One of the biggest problems that we faced as we expanded, let's look at the British Empire. Communications and supply lines. That was the biggest problem these empires face, right? You break the supply line, you break the communication, you can seriously injure the empire in question, the Roman Empire, the British Empire, I don't care who they are, right? And you overlay that onto a intergalactic kind of civilization. It's like trying to run the British Empire with carrier pigeons. Not really a good idea, right?
I've sold the same carrier pigeon, Mackie, on eBay about 30 times.
Well done. Well done. Right?
I love that meme.
But look, that's where we're at, though. I think Dave, maybe not. Well, actually, you can try. No, let's run it out with a discussion around the points we have raised. Then, right? So, life, as we know it, may not be the only life there is. In fact, it isn't. I don't know if you know this, but the very first life on Earth didn't live off oxygen. Okay, There's actually, about 4.5 billion years ago, they say the Earth formed, and it was just a few 100 million years later that life also arose on our world. Okay, it's thrived, and so forth. But 2 billion years after Earth first took shape, life almost ended. The atmosphere had slowly been altered by the gradual addition of oxygen, which proved to be fatal for the most common type of organism present on Earth at the time. For hundreds of millions of years, the Earth entered a horrific ice age which froze the entire surface, known today as Snowball Earth scenario. It was a disaster that almost ended life on Earth entirely, right? So to be clear, the very first life that evolved on Earth did not breathe oxygen. Oxygen killed off most of the life. And some of the extremophiles that are still alive today, you found near volcanic vents on the bottom of the ocean, etc., they're the survivors of that age.
Yeah.
Okay? They are the survivors that survived that particular catastrophic apocalyptic event. And oxygen-consuming life was born. Okay? But the life that originally inhabited this planet was not oxygen robust, not oxygen friendly. It essentially the free oxygen killed it. And oxygen is a great oxidizer, as the name suggests, right? So just to be very clear, right? We did not have an oxygen kind of life cycle initially on this planet.
And look, to add to the fire. This is the third generation star in this region, the Sun. The Sun wasn't formed at the beginning of the galaxy, at the universe, right? It wasn't. And there were two other stars in this region, because if this was a first gen star and we were a first gen planet, there wouldn't be uranium and gold on the planet. There just wouldn't be. Right? Those heavier elements are a product of the former stars. It's like living on a rubbish tip.
Mm-hmm.
If there's no rubbish tip and you're the first to make it, it's only what you put in. The second generations of people living on the rubbish tip end up discovering things that were the culmination of the last civilization, for instance. It's sort of like anthropology or paleontology. You're finding the remnants, and on our planet we have the existence of elements which shouldn't be here if it was a first gen. And so we've come to the conclusion, science has, that this is at least a third generation star, meaning that it had planets orbiting the star the last two times, and they were flung out and destroyed when it novaed. And the star has progressively gotten smaller on each new iteration. So the big ones don't last very long. They pop real quickly, and that's where we're at. So thinking about this in the context of the Fermi paradox, or even the Drake equation, that there could very well have been a civilization in this very neck of the woods a number of times. We don't know what form the planets were the last, times around. They could, in fact, have been massive Earths, or many more smaller ones, and all of them lived in a habitable zone that just happened, because the star was bigger, to be further away, right? We don't know. But we do know that they must have existed, and given enough time, given the right equations, and the right, this is a good area of the neighborhood to live in, if you know what I mean, it reasons that there was life already in this region. So, would you, as is postulated, are they just keeping a distance? You know, if we're driving down the road and there's a sign that says, you know, there's a hairpin coming up, you don't just blister into it at speed. You slow down so you can get around it, negotiate. When you see a sign in Australia that says, you know, there's koalas or there's kangaroos or something, you know, we're wary of it. While we may not see one, they are there. The same thing. Imagine if there was a little warning, you know, like Hitchhiker's Guide to the Galaxy, Mackie, mostly harmless. If that was what there was, and they had a prime directive and they'd stay away from us until we had true space flight, not what we've got, but, you know, if we have anti-gravity or something, then they show up, fantastic. But if they're already here and they've got to stay cloaked, or they, you know, that we'll cover off in further components of this show cycle, the ET question, irrational approach is what I had to name it because the name's too long. We'll find out next week.
And there's the music. Don't go away anywhere. I think Joe Bear is up with the roundtable after this. And donate if you can.
Absolutely. This has been David Mackey's Shiny Side Out on freedomslips.com. Check out our other shows and do like, share, and subscribe. Please share it. Take care, everyone. We'll see you next week.